So we're asked to find the area under the curve between 0 and pi over 2 for cosine of x. And so if you've been practicing with area methods, you could graph cosine of x, but you'll see that it's not a shape that makes a perfect quarter of a circle or anything like that. So you can't do it with those visual methods. What we have to do is find something called the antiderivative. And the antiderivative is just a function such that if you were to take its derivative, it'd turn back into this function. So we want to think of a function so that its derivative equals cosine of x. Look, we know the derivative of sine of x equals cosine of x, so that must be our antiderivative. The antiderivative of cosine of x is sine of x. Okay, so I know it still seems weird, so hang in there. Okay, so this is the next step. When you want to find the area under the curve, you can do something called take an antiderivative, which means figure out a function whose derivative is cosine of x. And then we got it. It's sine of x. If you take the derivative of sine, it makes cosine. Okay. And so once you've found your antiderivative, what do we do with these 0 and pi over 2? We usually make a vertical line like this to symbolize the limits of integration. We're going to plug in pi over 2 into this function. And then we're going to plug in 0 into this function. Okay, so sine pi over 2, if you're not sure what that is, sine is the y coordinates on the unit circle. So an angle of pi over 2 is 90 degrees. So that lands right here. So since it's the unit circle, this is 0, 1. And sine is the y coordinates in the unit circle. And then sine of 0 is just 0. So that makes 1. Okay? And so there we go. We've got our answer. This is equal to 1. Okay. So if that's your first time seeing an antiderivative, you're going to want to see a couple more basic antiderivative videos before you'll really get a good handle on how to do it. But that's the idea. If you want to find the area under the curve, you want to find the integral, then find the antiderivative. Find a function whose derivative would make cosine of x, and then evaluate those limits of integration just by plugging them in like I did.